Structural formulas show more than the number of atoms in a compound and the ratio between them. It shows how the atoms are put together. The simplest structural formula is the Lewis dot formula. That's what we've been practicing on the past couple of days. H2CO, capital H, capital C, capital O, is the molecular formula for a compound known as formaldehyde. It's the stuff in all the biological laboratory a lot of times where you'll see animal parts are stored in a liquid that's formaldehyde. This formula, though, doesn't show the structure. It only shows how many hydrogens, how many carbons, how many oxygens there are, and their ratio. For every 2 carbons, there's an oxygen and a carbon. I mean, for every 2 hydrogens, there's a carbon and oxygen. So it shows the ratio. To get a structural formula, you need to start with, at least this is the thought process, okay? Later in life, when you've done this a lot, you can jump to structural formulas. That's okay. For right now, when you're beginning to learn how to do structural formulas and how to think about it, you start with the electron dot notation. From the electron dot notation, then you show how the electrons are shared to get a sharing arrangement. And then from that, then you squeeze the electron dots in between the symbols for the atoms to make this Lewis dot formula. Okay, so that's stuff we've already done. We have also done some molecular shapes and the shape of bonds. And while those are highly related, they are 2 separate kinds of drawings. Everybody listening? It's really important for you to hear this and understand. The shape of a bond, if I draw a molecular shape that shows the shape of a bond, that's not the same kind of drawing as showing the stick figure molecular shape itself. Okay?
Is there any work that you need to give me?
I'm going to be assigning homework. Yes.
Am I going to know how to do it?
Probably not, unless you look at the video or you get the notes.
Yeah, I'll look at the video.
Okay.
Where it'd be on Saturday chemistry.
This is the homework I want to assign at the end of the period, right here. All right. Something we haven't done so far, and I'm just kind of taking a little bit of a slight detour to show you this because you need to know it. It's something called the Lewis formula. We've done nothing but Lewis dot formulas. I want to take a minute and talk about Lewis formulas. In a Lewis formula, you simply take shared pairs and replace them with lines. In a Lewis formula, you simply take shared pairs and replace them with lines. So between this carbon and this hydrogen, there's a line showing a bond. Any shared pair of electrons is a bond. Any shared pair of electrons is a bond. So this shared pair of electrons is a bond, and we're going to replace that shared pair with a line. Now these 4 electrons make 2 bonds. Any shared pair is a bond, so there's 2 bonds here. So here we need 2 lines. The lone pairs have to stay there. You just simply draw those as dots. Lone pairs remain as lone pairs as dots. Okay? Some more terminology that I want to review for a minute. This set of 4 electrons, we call that a double bond. So then this double line is also a double bond. These single sets of shared electrons are single bonds. So this single line here is a single bond. And the pairs of electrons that are not shared between two atoms, we just simply call it a lone pair. We've gone over this too. I want to repeat it again for emphasis. Each pair of electrons that share between two atoms is an overlapping or a single orbital that share between two atoms. Each pair of electrons between two atoms represents an orbital that's also shared between the two atoms. Therefore, any line between two atoms in the Lewis formula also represents an orbital that's being shared. Any orbital that's being shared is one bond. You can have a double bond, that's two bonds. Each time you have a bond, you've got a shared orbital. Yep. Any two electrons shared between atoms represents one orbital being shared. And a shared orbital is a bond. From these sorts of structural drawings, these are structural drawings, okay, we can get two different kinds of three-dimensional drawings. From these structural drawings, we can get two different kinds of three-dimensional drawings. In fact, there are others. There are lots of three-dimensional drawings. We are only dealing with a couple of them in here. Okay? One of the structural drawings, the 3D structural drawings, is a kind of stick figure drawing that just is called the molecular shape. The other is the shape, shows the actual shape of the bonds. I'm going to tie in all of this together here. Okay, first thing I want to do is to go through how do you get to the molecular shape from this Lewis dot formula. All right, you need to know this, what I'm about to say, you need to know it to understand how to do this right. Okay? A set, this is a key word, set of electrons is a lone pair. And or all the electrons shared between any two atoms. Okay, so a set then, a lone pair, that must be a set, and that must be a set. Or all the electrons share between two atoms. That means this makes up a set, that makes up a set, and these four electrons here make up a set. Okay? In our Lewis dot formula then, the lone pairs represent a set, the single lines represent a set, the double line is one set. To find the molecular shape, we're going to create an arrangement of sets of electrons. We're going to create an arrangement of sets of electrons that are as far apart as I can get them around the atom we're interested in. To create a molecular shape, we're going to create sets of electrons that are as far apart as I can get them around the atom we're interested in. The atom that's key here to find the shape of this molecule is this carbon, because everything is attached to it. Hydrogens are attached to it and oxygen is attached to it. So around carbon, I want to arrange 1, 2, 3 sets as far apart as I can get them in three-dimensional space. Well, that means they have to be 120 degrees apart. Now, one of the sets has 2 electrons. Another of the sets has 2 electrons. The third set has 4 electrons. Okay. From this drawing then, we're going to replace any sets of electrons that are actually shared in the Lewis dot formula. And we're going to replace that set with the atom symbol those electrons are shared with. So we're going to first put our central atom here, the one we're interested in here. And this is where you want to do stuff in pencil. I'm sorry if you hate to erase, but you should be doing it in pencil. It will help. We're going to redraw exactly the same drawing here. Okay. And we're going to, as I said, we're going to replace any sets of electrons. This is a set, that's a set, and that's a set. Any sets of electrons that in the Lewis dot formula are shared. We're going to replace that set with the atomic symbol it's shared with. Okay, so one of the lone pairs, or one of the pairs of electrons here around this carbon is shared with a hydrogen. So I need to pick one of these pairs and erase the lone pairs and replace it with a hydrogen symbol. One of the other sets, that's just a single pair of electrons, that would be this one right here in our three-dimensional drawing, is shared with a hydrogen. So I need to erase the lone pair, the pair of electrons down here. It's not a lone pair, it's a shared pair, and replace it with the symbol for that hydrogen. This set of electrons, the 4 electrons, are shared with an oxygen. So I need to replace that set of 4 then with the symbol for oxygen.
So you get those 3 sets from the 3 that are around carbon.
In the Lewis dot formula. Correct.
You don't use the lone pairs?
Well, there's no lone pairs around the carbon. There are lone pairs around the oxygen, but we don't need to worry about that. All we care about right now are the number of the sets of electrons around the atom we're interested in. And it's just because we're not trying to find the shape of the oxygen, we're trying to find the shape of the molecule, and everything is attached to this carbon. So we're looking at how things are attached to the backbone of the molecule. Okay?